Alright, this question is from exercise 3.4, question 15. It's to show that tan 3 theta is equal to 3 tan theta, tan cubed theta. Alright, so start with the left hand side. No need to set it out formally like a proof because it's just asking you to show, so it's not asking you to do a proof. So left hand side equals tan 3 theta, so that's equal to sine of 3 theta over cos of 3 theta. Right, so you need to think about substituting in for sine and cos, the expressions that we know for sine of n theta. So sine of 3 theta will be z to the power of 3, subtract z to the power of minus 3, all over 2i. And cos of 3 theta will be z to the power of 3 plus z to the power of negative 3, and only over 2. So don't forget the I there for your sine. Right, so here we've got a fraction divided by fraction, so our fraction work from middle school multiplied by the reciprocal of this denominator, so 2 over. Those 2's cancel out, leaving z to the power of 3 it's all of that multiplied by I, so the brackets are necessary there. Right, so that's the left hand side. Now we'll go to the right hand side. Alright, so for the right hand side we have 3 tan theta cubed Alright, so this is going to be similar, it's just going to be more annoying really, it's just more substitutions. So once again we want to substitute in our sine over cos for tan theta, and then simplify before you do your substitutions, otherwise it's going to be very annoying. So it's equal to 3 sine theta over cos theta, that's this one here. Now tan cubed theta, that's going, I'll do it the long way, that's going to be sine theta over cos theta all cubed. And it's going to be 1 subtract 3, similar to the numerator, this is going to be sine theta over cos theta squared. Right, so now let's do the cubed and the square here. So that would be sine cubed theta over cos squared theta. Right, so we've got a pretty nasty fraction there. If we start to substitute in now for our expressions for sine theta, that's going to get pretty horrible. So let's try to simplify this fraction first, just to save all that extra work. So let's look at the numerator. This one here has to be the same as this denominator, so we can do the subtraction. So we're going to multiply the denominator and the numerator by cos squared theta. So it'll be 3 sine theta cos squared theta over cos cubed theta. And now the denominator, once again, to do this subtraction, this 1 needs to be expressed as a fraction where the denominator is the same as this one. So that's cos squared theta, subtract Alright, so now we can do the subtractions in the numerator and the denominator. So subtract from here. Subtract sine cube theta. Hopefully you remember the denominators stay the same. And likewise with the denominator, it's going to be cos squared theta all over cos squared theta. Alright, if possible, factorise. So I can factorise this numerator here. We can take out a sine theta, so it's sine theta can't read my own writing. All over. We can't simplify that. We can substitute in for sine squared theta, we can substitute in 1 minus cos squared theta, so then we might be able to do some simplifying, so we'll do that. And we'll be able to do that here as well. Substitute in either for cos squared theta or sine squared theta, that should help reduce the amount of work that you have to do. So we'll do that here, cos squared theta. So I've just substituted it in 1 minus cos squared theta there. Alright, so I'm gonna do that here. I'm gonna substitute 1 minus sine squared theta here. Hopefully that just simplifies it a bit. So I've substituted 1 minus sine squared theta for that. So minus 3 times 1 is minus 3. Minus 3 times minus cos squared theta will be plus 3 cos squared theta. So you can see how that can simplify now because we can they're like terms, so we can add them. All right, so the numerator, we've got sine theta outside of 3, subtract 3 sine squared theta, subtracting a sine squared theta, so we can simplify that. And our denominator now can be written as 4 cos squared theta minus 1 over cos squared theta. Okay, do not think about cancelling those. You can only cancel common factors. This is not a factor of the numerator. It's a factor of this term, but it's not a factor of the expression in the numerator. So do not cancel those out. All right, so let's just finish simplifying this numerator here. So we've got sine theta, and this will be 3, subtracting 3 of these, then subtracting 1 more of these, so that's subtracting 4. All over, running out of room. Hopefully you can see down there. 4 cos squared theta subtract 3. All right. Now, we've got a fraction divided by a fraction, so we can simplify further. So let's multiply by the reciprocal. Oops, sorry. We're multiplying by the reciprocal. All right, so that cancels out, and we cancel out the cube here. So that leaves in the numerator just the sine theta, 3 subtract 4 sine squared theta, and in the denominator that leaves us with cos theta multiplied by 4 cos squared theta subtract 3. All right, so now we've got to the point where we can substitute in for our sines and our coses. All right, so if we look back to the original, I know we've done a fair bit of work, but if we were going to substitute in here, we had 1, 2, 3, 4, 5, 6 substitutions, as well as these cubes that we had to do. So we have simplified a lot of work to get there. So hopefully it wasn't a waste of time. So from here, substituting in for sine theta. So sine theta is z subtract z to the power of -1 over 2i times pi 3 subtract 4. Substituting in for sine squared theta, that will be sine theta is z subtract z to the power of -1 over 2i, so we're going to be squaring that. So we have to do a square, but that's going to be easier than a cube. Alright, so substituting for cos theta, plus z to the power of -1, over 2, and again squaring this time our expression for cos theta, we're squaring it, subtract 3. Now hopefully all of this can be expanded and simplified to look like that, and if it doesn't, I'm going to cry. Alright, so 3 times this, so we're going to have 3z subtract 3z to the power of -1 over 2i, subtracting 4 times, or this times all of this. Alright, so that's going to be 4 times z subtract z to the power of -1 over 2i, so we've got that times the 4, now we need to times by this squared. So this squared is going to be z squared subtract 2z z to the power of -1 plus z to the power of -2 all over 4i squared. So 4i squared is -1, so that's going to be over -4. Alright, so a lot of algebra there in that one line, and it's going to be similar down here. Alright, so the 4 times that, 4 times z plus z to the power of -1 over 2. Now times it by this squared, so similar to what we did above, so z squared plus 2 plus z to the power of -2 all over 4. So we've done the multiplication of the factor outside the bracket by the first term inside, and now we have to multiply this by the -3. Alright, so let's simplify this, all of this hopefully to this. Always keep looking back at what you're trying to do. Okay, so first of all, let's cancel out those 4's. We can cancel out that 4 and that 4, and now that's negative and that's negative, so we cancel out the negative and make that plus, so that's like -4 divided by -4, which is +1. Okay, so from here we can simplify further. We can simplify these terms. Z times z to the power of -1, that's like z to the power of 1 times z to the power of -1, so that's going to be z to the power of 0, which is 1. Alright, so here we can simplify this middle term just to be 2 times 1 and -2 times 1. So let's do that first. Let's just make this a bit neater. So 3z subtract 3z to -1 over 2i plus z subtract z to the power of -1 over 2i times by z squared. Remember, this here is going to become just the subtraction of 2 plus, that's 2 plus z to the power of -2, and that was all over 1. Okay, because that cancelled out. Now that's all over this denominator here, which is z plus z to the power of negative 1 over 2 times by z squared. This is just going to simplify just to be 2 plus z to the power of negative 2, subtracting 3z plus 3z to the power of negative 1 all over 2. Alright, so we're still subtracting this fraction. That's why that remained positive, because even though it's negative 3 out here, we're still subtracting this fraction, which means we're subtracting 3z over 2. So we're subtracting 3z over 2, and we're subtracting 3z to the power of negative 1 over 2. Alright, from here, we want to think about simplifying, so hopefully I can do that in a couple of lines. What do we want to do? Alright, we're going to have to do this multiplication and this multiplication here. That's like a fraction over 1. So let's do these multiplications. Once we've done these multiplications, we can then do the addition and we can do the subtraction. Alright, so from here, this stays the same. We can't do this anything with this at the moment until we've done the multiplication here, so then we can think about adding. Right, so multiply the numerators. This is going to be a little bit annoying, so the first term needs multiplied by all of this expression, and then we need to subtract the second term, which is multiplied by all of this. So z times z squared gives us z cubed, z times negative 2 gives us negative 2z, z times this one. Alright, so therefore that's going to be plus, now z to the power of 1 times z to the power of negative 2. Okay, 1 plus negative 2 is negative 1, so that's going to simplify to z to the power of negative 1. And then we are subtracting z to the power of negative 1 times z to the power of 2. Alright, so negative 1 plus 2 will give us z to the power of 1. Subtraction and subtraction, so this is going to be the addition of 2z to the power of negative 1. Subtraction and addition, so it's going to be subtraction of z to the power of negative 3. Having fun yet? All over that times that 2i. So see, we can now do this addition, and hopefully when we do that addition we can cancel some of these terms. Alright, so we're going to do the same down here. Alright, z times z squared is z cubed, z times 2 is plus 2z, z times z to the power of negative 1, so that's like z to the power of 1, times z to the power of negative 2, so it's going to be plus z to the power of negative 1. Okay, the next term, so plus z to the power of 1, plus 2z to the power of negative 1, plus z to the power of negative 3. Okay, so that's all over 2, and once again we've got the subtraction of 3z plus 3z to the power of negative 1 over 2. Alright, so from here we can now do this addition, and hopefully we can then end up with this. Alright, so we can do this addition, so it's going to be all of this, all the numerator added together. So 3z, subtract that, plus all of this. Alright, so let's do it the long way. 3z minus 3z to the power of negative 1 plus z cubed minus 2z plus z to the power of now that's all over 2i, and all of that's over that, subtract this. So we need to be careful here, it's like a bracket there, we're subtracting that numerator, we're subtracting all of it. So z cubed plus 2z plus z to the power of negative 1 so we are subtracting the 3z and we're subtracting the 3z to the power of negative 1. Now all of that is just over 2. You can see that, you're a genius. Okay, so let's hopefully start cancelling. What do we got? Let's start with the z's. We've got 3z, subtract 2z, subtracting 1z. So 3z, subtract 2z, subtract 1z, or z to the power of 1 is just 1z. So that cancels out. And then we've got our negative 1, subtraction of 3z to the power of negative 1, plus one of them, plus another 2 of them. Excellent. That all cancels out. And then you've got z to the power of 3, subtract z to the power of negative 3. Woohoo! Okay, all over 2i. Now I'm hoping this then cancels out to be 2, because it technically, oh no, sorry, that's not right. Hopefully it simplifies to this times something like that. Sorry, I'm getting too far ahead of myself. All right, so let's start with z to the power of 3. Okay, so z to the power of 3, we can't cancel that out, which is good because we want that. Likewise, z to the power of negative 3, that's not going to cancel out, which is good because we want that. All right, so hopefully these z's cancel out. 2z plus z is 3z, subtract 3z. All right, next one, z to the power of negative 1 plus 2 of them, so we've got 3 of them, and then we're subtracting 3 of them. All right, good. That's leaving us with what we want. Okay, so these 2's will cancel out, and we're going to have what we wanted. So from there, without covering that up, you can see that we're going to end up with z to the power of 3, subtract z to the power of negative 3, all over 2i, oh, those equal signs, all over z to the power of 3, plus z to the power of negative 3, all over 2. All right, so you've got a fraction divided by a fraction. So therefore, let's do z to the power of 3, subtract z to the power of negative 3, over 2i, multiplied by the reciprocal, z to the power of 3, plus z to the power of negative 3. Cancel that out. We're left with z to the power of 3, subtract z to the power of negative 3, over z to the power of 3, plus z to the power of negative 3, all multiplied by I. That, thankfully, equals that. So we can say it's equal to the left-hand side. No need for QED, but if you want to, do it.